Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here at the Bakersfield Airport, live at the Bakersfield Jet Center, and this is definitely not the quietest place in Bakersfield, but we're here anyway, and we're here today with Ryan Crowell from the Bakersfield Jet Center. Ryan, thanks for your time, man.
Thank you.
Glad you could be here.
Yeah, glad
it was nice and quiet for us quite a while, but of course, this is a busy place.
It's an airport, so
it's an airport.
we have airplanes.
That's part of the deal. That's it. So can you tell us a little bit about what we're standing in front of right here?
Well, we're here at the Bakersfield Jet Center. We are a corporate aircraft service company, really,
right.
And this is one of the airplanes that we use to transport people around for business and corporate meetings, that kind of thing.
Right.
So this is a Beechcraft Baron. It's a 58 model Baron,
okay.
And this airplane's been in production more or less for about the last 40 years.
Okay.
Very popular airplane. It's a piston airplane. So that means it has a reciprocating engine, 6 cylinders per side, flat arrangement, similar to an old Volkswagen.
Okay. Gotcha.
So we have 2 engines here. We'll kind of walk around and
sure.
I'll show you a little bit about the airplane.
All
so
right.
we have 2 engines. Each one's 300 horsepower a piece.
All right.
So a total of 600 horsepower for this airplane. Kind of cool. It's certified to fly through all kinds of weather and ice and really anything you need to. This is kind of a regional airplane. Take
Right.
you around California,
Right.
over maybe Las Vegas or San Diego. It'll do all kinds of stuff like that. Carry up to 6 people, so pilot plus 5 others.
Okay.
So we'll take you around here and we'll show you inside.
Good deal. Do you need 2 pilots to fly this plane? I mean, a lot of planes that people are on have 2 pilots, right?
Yeah,
Like pilot and co-pilot.
Just one for this airplane.
Okay.
Yeah, single pilot. We've got the back here, so nice and comfortable for up to 4 people in the back.
And everybody gets to sit facing each other, so
Yeah.
they can have a nice little conversation while they're going to their destination.
Absolutely. And we'll jump inside and I'll show you what it looks like from the cockpit.
All right. Good deal. All right. So it has room for 2, right?
Yeah, room for 2.
Up here. But only one person necessary to actually fly it.
Right. Only
Okay.
one necessary. We've got a glass cockpit, we call it. So it's just computer screens that replace a lot of the old round dials that you used to see in airplanes.
Oh, right.
Technology's gotten a lot better. We do have some backup instruments over here that we use for
That are not digital. So
correct.
in case your digital stuff goes down, you can have some readings over here that are still going to work. And we
Yeah.
talked a little bit earlier too, and I want to make another mention of it, the fact that you really, as a pilot, have to do some mental math, right?
Absolutely.
Because this stuff is going to do all kinds of calculations for you, but at the same time, this is not always going to be 100%. We know that computers don't always function like we want them to, and if you can do some math in your head, then at least you'll have an idea of what this should say, and certainly be able to make some calculations without having to rely on that completely.
Right, and the computer has a lot of backups to it.
Okay.
But there's some things that are just faster. We could program a computer to figure out how fast we need to descend.
Right.
If we have, say 10 minutes to the destination, we have to lose 10,000 feet, that's 1,000 feet a minute.
Yeah.
That's real quick.
Sure.
If you can do that in your head, it just makes life a little easier, and it's
Right.
quicker than programming a computer to tell you how to do it.
Right.
But this,
So how long have you been doing this? How long have you personally been a pilot?
I've been a pilot for about 22 years.
Okay.
I've been here at Bakersfield Jet Center and Lloyd's Aviation for about 13 years.
All right. And how long do you think it took you, if you can remember back, when you first started as a pilot, to kind of get some of this stuff down, to feel comfortable doing that mental math in your head? I mean, it goes through, there's a lot of training that goes along with being a pilot, right?
There is, and you start out in small airplanes,
Right.
and about the time you get that figured out, you jump up to a bigger one,
Right.
and then you kind of start all over. It's like flexing a muscle. You got to get your head to build up to the faster airplane. So you got to
Right.
make decisions faster. You got to make calculations faster.
Right.
You just have to mentally keep up with the faster airplane and the more complex airplane. We have 2 engines here.
Okay.
So there's twice as many things to pay attention to.
Right.
We've got 2 gauges for everything. We've got 2 levers for everything.
Right.
So just more to pay attention to. And you know, this is an airplane that's moving about 170 knots.
Okay, so now we're getting into some terms in aviation that maybe we don't use as often or ever actually in a car. Tell us about a knot. What is a knot?
So a knot is a nautical mile per hour. So
Okay.
we think miles per hour in our car.
Right.
That's actually a statute mile, 5,280 feet.
Right.
A nautical mile comes from nautical or the sea,
Okay.
is 6,013 feet. So it's 15%. So if you take knots at 170 and add 15%, you get miles per hour. It's 15%
Okay.
longer.
All right. Gotcha.
So this is about 170 knots. An airplane that you would train in would be more around 90 knots.
Okay.
So you're going 80
Gotcha.
knots faster. Everything's happening that much faster to get in,
Right.
and you've got 2 of everything.
Right.
So that's
Lots
why.
of things to keep in your mind. No
yeah,
doubt.
yeah,
Huh.
and it's fun. It's challenging because
Yeah.
as you grow in the airplanes and as you get faster and faster, you master something new,
Right.
and then you go, okay, where's the next one?
Where's the next one? That's
Yeah.
right. And of course, the next step is going to require some new and different training as well, because you have a new
Right.
machine to master and you're going faster.
Right.
Lots of different variables. Well, we're really excited to know about this process, but we're also excited to know about what other things you have around here. So when we come back, then we're going to go ahead and get to another aircraft. But man, right now, we are really interested in what's going on here and the information that we're being given. We're back here live at the Bakersfield Jet Center with Ryan Crowell. And we just got a chance to see some amazing pieces of machinery where the plane was a little smaller. We're next to a little bit bigger plane. But before we get to exactly what's going on with this machine here, Ryan, I want you to explain a little bit about the general idea of aviation. Can you tell us a little bit, since we're standing by this wing here, can you tell us a little bit about lift and why an airplane flies? Because it's a big piece of metal. How do we get that thing off the ground?
Sure. Well, we've learned a lot over the years from birds and observation.
Right.
And we owe a lot to Mr. Bernoulli and his principle.
Right.
That's really how an airplane flies. So the way a wing is shaped, you'll notice that it's curved on the top and that it's relatively flat on the bottom.
Right.
What that does is it creates, as the air flows, it creates a Venturi effect over the top. So the airflow actually speeds up here and creates a low pressure. So you get a low
Right.
pressure right about here over the wing and a relative high pressure under the wing. Well, we know that air always goes from high to low.
Right.
And we create a high pressure to low pressure difference, then that creates lift in that direction. And in our case, it's vertical.
Right.
And we use that to then obviously lift the airplane, but we also use the same principle to control the airplane.
Okay.
So for example, we use the tail
Right.
to create and destroy lift so we can tilt the airplane or pitch the airplane.
Okay.
We can pitch it up and down using the elevator in the back. It's just a small wing. We call them airfoils. If they happen to be here, it's a wing. If it's there, it's an elevator.
Okay.
And then we can manipulate the wing out on the wing tip there with an aileron, and we can increase lift on one side and decrease it on another and cause the airplane to bank.
That's how we can turn.
And
Yeah.
then really what turns the airplane is when we take that lift that's pointed straight up, we take that vector and we rotate it.
Uh-huh.
So now that it's pointed this way, we have a vertical component and we have a horizontal component of lift.
Right.
And it's that horizontal component of lift that turns the airplane.
Oh, wow. Good deal. And the faster you go, the more lift you get. Is that correct?
Yeah, that is
Okay.
correct. The faster we go, the faster we can get the air to flow over the top of this wing,
Right.
the greater pressure difference we can create, and therefore the more lift we can use.
Gotcha. So we go from a smaller machine to a bigger machine and we get to go faster. Now, we talked a little bit about all these amazing things that make this piece of metal go in the air. What are some problems that you as a pilot have to worry about in the air? Like, we've heard a little bit about ice, right? You can get ice
Right.
on a wing?
Yeah, sure. Well, we're flying through the air, so there's clouds and rain and ice and hail.
Right.
So we have to pay attention to that.
Right.
When we get this nice smooth airflow over the wing, it works great. But when you get ice on it, it disrupts the airflow,
Yeah.
and now we have a problem.
Right.
So what we do on this particular airplane is we heat this leading edge. That's why it's not painted. So we heat this leading edge all the way down, and it keeps the ice off the wing.
Right.
So we also do the same thing if you look at the engine inlet.
Oh, okay.
The last thing you want is ice building up on the front of that, and then it breaks loose and right through the engine.
Right.
So
that would be a problem.
Yeah, so we heat the engine lip that we call it.
Yeah.
And that keeps the ice from forming and going into the engine.
Gotcha. So we want to avoid ice, but it's okay to fly through clouds.
It is.
Right, but what's the danger there if we fly through a cloud? We got to worry about something else, right?
Well, just in the clouds is really just like driving through fog.
Okay.
So you can't see where you're going.
Right.
But it's really no different than maybe standing in the steam in your shower or driving through the fog of Bakersfield. You just can't see. So now you have to create artificial horizons or instruments that tell you where you are and how the airplane is oriented so that you don't get disoriented.
Gotcha. And then static electricity, is that where we get that from as well?
Yeah, we have static electricity when we fly through clouds because it creates friction over the wing.
Okay.
And so we have on the back of this wing, you can see there's a red one on the end.
Right.
The other two, those are called static wicks, and they discharge static electricity off of the airplane.
Okay, gotcha. That totally makes sense. All right, so we have some things that we're interested in knowing about how we can stay as safe as possible.
Right.
Now, we're going to get off the ground because of lift, and we're going to be able to fly through the air as fast as we can to get even more lift, but then we got to come back to the ground, right?
Right.
So I know that one of my questions has always been, these tires on this machine have to be different than the tires on my car.
Sure.
Can you tell us a little bit about the tires and the landing gear here?
So the tire here on this particular airplane, it's a thicker, it's a 10 ply tire.
Okay.
And that tire is rated to 165 miles an hour because that airplane is landing at about 100 to 115 miles an hour, and that tire has to go from zero, where it's stopped in the air, to as soon as it touches down, it has to spin up to 115 miles an hour right now.
Sure.
So it's got to be a beefy tire, it's got to be a sturdy tire. But then once we stop, we use our brakes, which create heat.
Yeah.
That thing has 200 psi in it, pounds per square inch. You get it too hot and it would blow up. So we actually have fuse plugs in there that if it does get too hot, they melt, let the air out, and now it's not a safety hazard.
Gotcha. And this all takes a lot of engineering, right? A lot of engineering.
Yeah.
And hopefully not by making too many mistakes, but that's one way to learn. But the other way we learn, of course, is we can do some math ahead of time and be able to figure out all these problems beforehand and avoid them, right?
Yeah.
Wow, okay, so we've gotten off the ground, we've gotten back to the ground safely. We want to know a little bit more when we come back in the next section about what the difference is between the aircraft that we saw earlier and this one here.
Sure.
That one has a propeller, this one doesn't. I've always wondered, what's the difference? Why would we go from an airplane that has a propeller to one that doesn't? We're back here at the Bakersfield Jet Center. Beautiful October day, and we told you when we left last time that we were going to talk about something that I'm really curious about. So Ryan, if you can give us a little tutorial. The first aircraft that we looked at had a propeller, the second one was a jet. Why does this plane fly? Tell us a little bit about the propeller part.
So the propeller is really just an airfoil or a wing that's turned on its side and we spin it around. So if you were to look at the cross section of this propeller, you'll see that the top half is curved just like a wing and the back half is straight. So we use the same Bernoulli's principle to create lift, except we've turned it and now the lift is this way and we call it thrust.
Okay.
And in addition, the air coming off the back of this is being accelerated over the top like we said before, and it's accelerated backwards. So when we take air and accelerate it, we know that for every action there's an equal and opposite reaction.
Right.
So if we accelerate it this way, we get thrust that way.
So air goes this way and the plane goes forward.
Right.
Gotcha.
So when we spin this, we get air that's, as the prop's moving, we get air that's being accelerated backwards. So if we remember that force equals mass times acceleration. So in this case, the mass is the air,
right,
and we're accelerating it that way, so the force is this way.
Okay.
So that's how we get thrust. Now that works great as long as there's plenty of mass.
Okay.
So this is a big, if you take the propeller that's spinning this way, this disc that it spins through, it can take this much air and accelerate it. So it's a lot of mass, and it accelerates it a little bit so we can get a force.
Gotcha.
So
if you have one propeller on the front, it's going to accelerate some air. you have two propellers like this one does, one on each wing, you're going to accelerate more air.
Yeah.
And then at some point we're going to reach a maximum, and you can only accelerate air so quickly, right? So we like to go faster.
So we have those two, mass and acceleration, to play with,
right,
to get the equal force.
Sure.
Well, this takes a lot of mass and accelerates it a little. But as you go up in altitude, the air gets thinner and thinner and thinner.
Right.
So this jet over here can go up to 45,000 feet.
All right.
So what it does, there's no air up there.
Yeah.
The mass is gone.
Right.
So what it does is it takes a little bit of air, and at first it squeezes it with compressors. Those are what you're seeing mostly when you look down it. So we have we call that an N1 fan, but then behind that we have compressors that are squeezing and compressing the air so that we have something to burn. We're taking a little bit of air, then we light it on fire, and it accelerates out the back. So in this case, we're putting a lot of gas in,
right,
and we're taking a little bit of mass, but we're accelerating it a whole lot.
Okay.
So as you go up in altitude, there's not much mass to deal with. So the propeller, the higher you go, the less efficient it becomes.
Right.
So in a jet, you take that air that's there, which isn't much, you squeeze it, compress it, and then you light it on fire, and it accelerates like crazy out the back.
Right.
And that's why a jet is much more efficient as you go up in altitude. And the advantage to go higher in altitude is that there's less air, so it's difficult on the engine, but there's also less drag, so the airplane goes faster. The higher we go, the less drag and the faster an airplane can go for the same amount of thrust.
Right. Wow. So we have a propeller airplane and we have a jet airplane. And most of the commercial airlines we see are jet airplanes.
Right.
How many actual engines does this aircraft have? Has two?
This has two, one just like it on either side.
Right. And then bigger airplanes have more than two engines, or are they mostly two?
Most airplanes now have just two engines.
Okay,
yeah,
gotcha.
The engines are getting more powerful and more reliable, so the days of 4-engine airplanes may be behind us.
Okay, and just a little bit real quick about the fuel. Tell us a little bit about the fuel, the difference obviously between what I put in my car and what we put here in this plane. It's got to burn differently, it's got to burn at a different temperature, it's got to burn at a higher altitude, obviously.
Yeah, so there's a lot of things that we have to be careful of. We have a lot of filters as it goes through the system.
Right.
We also heat the fuel in an airplane like this because at 45,000 feet, the air is about 65 degrees below 0 Celsius.
Wow.
So it's very cold. We can't have any ice in the fuel system. So we have filters, we have ways, and then we heat it using actually hot engine oil. We use it like a radiator, and we heat the fuel so that it doesn't freeze before it goes into the engine. All things that we have to think about from an engineering perspective.
Right, and so there's all kinds of checks and balances here. If one system goes down, you got to be able to compensate another way, and certainly we wouldn't want that to happen, but if it does, you got to have a backup plan.
Right, and in a lot of the systems in airplanes, we have two engines. We have backup electronic systems. We have emergency extension. Like if we go to put the landing gear down and the hydraulics don't work, we have a bottle in the airplane that blows it down.
Right.
So we have just different ways to do that.
Wow, that's so cool. Man, we're so grateful for the time you spent with us today. I know I learned a lot, and a lot of people, a lot of viewers got to learn a lot as well. I want to give you this wonderful Do the Math tile that maybe you can add to the inside of your office there. Really appreciate your time. Thanks so much for sharing some things about aviation. If you had to tell a student, what's the one subject they need to master in order to be a pilot?
Well, math is obviously very, very important.
That's the right
to be
answer.
A pilot. Math, physics, aerodynamics, all of that, but it all comes down to math.
Gotcha.
And they all center around that.
Wonderful. Thanks again for your time.